If you live in a small unit or apartment, does that mean that you can't operate HF amateur radio? The good news is that provided you've got a balcony or a courtyard, you probably can, and with surprisingly good results. You can get on air successfully with a magnetic loop, such as you see here. Unfortunately, a lot of magnetic loops are designed for lightweight, portable or QRP use. A loop like this may be great for use when walking around, but as a home station may have some limitations. You add up all those losses and they can be quite significant. For instance, the penalty of using 5 watts instead of 100 watts is 13 dB, or a 20 times ratio. And lightweight construction may mean higher resistance, and you can probably add another 3 or 6 dB on your losses there. 5 watts to a lightweight loop like this may be almost 20 dB down compared with 100 watts to a heavier duty loop. It's the same diameter as the lightweight pedestrian mobile magnetic loop you saw before, but it's a lot heavier. It can take 100 watts without a problem. It's thus more suitable for home station use. I'm using 3 metres of copper tubing available in that length from Bunnings. The copper tubing is 19mm in diameter and can easily be bent by hand to form a circle. The main worry you might have with bigger loops is what to do about the capacitor, because large high power loops like this typically use a vacuum variable type. They can be quite expensive, and if you're looking for a cheap weekend project, they may be above your budget. Another thing you could do is to use a high power transmitting variable capacitor, but again they can be pricey and you might not have one spare. And so I've used an alternative, Coax cable as the loop's capacitor. The only trade-off with this is that the loop is monoband only, in this case covering 7 MHz. Admittedly, a slightly bigger loop would be optimum for that band. If you could get material in 5 metre lengths or so, then that would be near the ideal length. Nevertheless, this 3 metre diameter loop gives surprisingly good results on 40 metres, as you'll hear later on. At the top of the antenna, where the vacuum variable capacitor would normally be, is the capacitor formed from RG213 coax cable. I'm also using a bit of irrigation tubing purely for mechanical rigidity. The coax cable is simply soldered to the end of the copper pipe. A normal soldering iron won't be good enough here. In this case I used a cheap blowtorch, and although it's a bit of a mess, there is a fairly good connection here. RG213 has a capacitance of about 1 picofarad per centimetre. In this case I needed about 185 centimetres, though your results will vary, this being for a loop that resonates on 7 MHz. At its end is a small variable capacitor made out of printed circuit board. That provides fine frequency coverage, for instance within a band. The top part has a slit sawed through the middle to provide 2 separate plates, one for the centre and one for the outer conductor of the capacitor coax. Now the slit must be a little bit wider than a hacksaw blade. If not, then your capacitance will be higher, but you'll get arc over, as I found out. Another piece of circuit board material operates as the slider. The greater the overlap, the greater the capacitance, and the lower the loop's resonant frequency. A capacitor like this might give you a tuning range of around 100 kHz. No doubt you'll be able to experiment and give it full band coverage if you want. The noise you hear is the 7 meg receiver in the other room. Now you can see the effect when I add some capacitance. Down at the bottom is the coupling loop. This is not electrically connected to the main copper loop. Its material is much less critical. In this case, I'm using extension cable with all 3 cores tied together. One part goes to the braid of the feed line and the other part to the inner conductor. You may need to adjust its position slightly for lowest SWR, but when done you should get 1:1 at your resonant frequency. The loop's bandwidth is very narrow, which indicates its high Q and likely high efficiency. I get around 18 kHz between 2:1 SWR points. You can tell the antenna is high Q when you touch it and listen to the effect on the received noise. Note the RF voltages at this point are very high, and you shouldn't touch it while transmitting.
Okay, back to me, Peter. Thank you for that, Peter. You're 5 and 7, Peter, by the way. It's a Tassie on the magnetic loop, and 5 and 8, 5 and 9 on the full-size antenna. So that loop works well, Peter, for sure.
Yeah, the VK3YE is LKSH. Fine business there, Peter. Well, that magnetic loop is doing a great job for you. You've dropped to a 5 and an 8 on that, but on the full-size antenna, you're 5 and 9 plus 5. 5 and 9 plus 5. So it's quite a difference, but considering the fact that it's blowed out, there was only one need to say it's a great signal there, Peter. Okay, to make your best very good evening, Peter. You're a very solid 5 and 9. Very, very solid 5 and 9 here on the River Murray. And that magnetic loop is certainly doing the job, Peter. VK3, Yankee Echo, VK5, a big RB. On the antenna you first contacted me on, you were 5 by 7 taking to 5 by 8. When you switched over to the G5RB, you were 5 and 9 plus 5.
VK3YE from VK7GG, and yeah, transmitting on that NVV, nothing special, but no, you're 5 and 9 plus about, I did a fraction of it, about 5 dBs or so over 9 on your loop antenna, Peter. And no, really good. That's fantastic.
So, what are you waiting for? Pop down to your hardware store today and buy all the bits you need to build a high-power magnetic loop. Put those together and in no time you'll be on air with a signal others won't believe from such a tiny antenna.